diagrams today and how phase diagrams are useful for finding out about phase changes. So let's begin. Here is our first graph, which is a phase diagram. And as you see, the phase diagram has two variables, and the two variables are pressure and temperature. So look at the phase diagram. We have pressure as y-axis and we have temperature in Celsius as our x-axis. And the graph has three different curved lines. It looks like kind of Y-shaped structure over here that divides the area into three different parts. And I want to tell you something. The first one is solid, second is liquid, and third is gas. It is very easy to remember. I remember this by a phrase, Sam likes gum. So, S for solid, Sam likes and gum is the simple one, right? Now, once when you know which area corresponds to which state of matter, it is easy. If you know a particular pressure and temperature, and if you know the substance is in this area, that will be solid. If it is in this area, it's liquid, and over here, that will be gas. And then depending upon the conditions, we can figure out, is it going to go from solid to liquid or liquid to solid, or all the changes, and we can find out if it is either one of those phase changes occurring there. There is one more important thing. There is this point when all of those three curved lines meet, and that is called as triple point. So let's find out what triple point stands for. But before that, let me explain to you what is phase equilibrium. A phase equilibrium is when we have the changes in two phases, but the change one side is always equal to the opposite side. For example, if we are going to go from solid to liquid, there is a rate by which liquid gets converted to solid, and the both of them will have exactly same rate change. That is the phase equilibrium. How do we know it is a phase equilibrium? If a point is on the line, on that curved line, so that will be always an equilibrium condition, equilibrium state. And we already talked about triple point. Triple point is the one where we have all three states, solid plus liquid plus gas, all of them coexist together at the same point. So what is the use of phase diagram which we are learning? The phase diagram is used to identify which state of the substance is there for a given pressure and temperature, and it's also used for identify or predict the changes for any substances if we know the initial and final variables for a particular system. So let's take one example here. Here is a phase diagram for carbon dioxide, and you know this is Sam, so that is solid, likes, so that is liquid, and gum, so that stands for gas. And now let's find out what we have. The first one is we have a sample of carbon dioxide at temperature -100 and a pressure of 100 atmosphere. If I look up with that point, if I go up and if I go up here, my point will come somewhere around here, which corresponds to the given temperature and pressure. So what is my point? It's in solid. So there you go. Your answer for first question is a solid. Second one is you're taking the sample which you found here and decreasing the pressure to 0.01. So now our new point will have a pressure equal to 0.01 and it will have same temperature, so that will be over here. So what is the state? The state which we have is gas. That means the substance is going from solid to gas. And if it goes from solid to gas without getting converted to liquid, what is it called? You know it. It's called sublimation. Okay, last question. The last question which we have here is, if you take the sample from part A and if you move the temperature to 20 degree. So we have same pressure, but now the temperature should be 20 degree, and if you actually get that point will be somewhere over here. So we are going to liquid. From solid, we are going to liquid. What is that called? That is called melting, as you all know. So look how simple it is. By looking at the phase diagrams, you can find out what state the substance exists at that particular condition, and you can easily predict which change of state it's going to go through. So we can say, is it going to be condensation, is it going to be sublimation, is it going to be freezing and melting, and all of that. And all this could be done just simply by just analyzing the information, the data from your phase diagram. So you know, phase diagram is very important. So I hope you understood what phase diagram is, and you can answer more questions on that. And